Welcome to the first dimensional modeling lecture. We have looked at the why data warehouse is needed, what is the difference between the data warehouse and a standard OLTP system, and also we looked at how the requirement elicitation is different from a standard project. So now we are stepping into our first designing modeling aspect of data warehousing. So if you look at, we are looking at few concepts here. We are looking at fact, measure, and dimension concepts. So if you look at data warehousing, we have events. Now, for example, ordering is an event. When you pay say employer salary, that's an event. So when there are multiple events, there should be a way to measure that event. How do we measure that event? For example, if when we are issuing an order, there can be order quantities, number of items, total amount. So those are the measurement for that particular event. And also, apart from these measurements, and how do we analyze those measurements? Now we can say the total sales is this much. But rather than just saying that, we can say, okay, for this particular product, these are the amounts. For this particular categories, these are the amounts. For during weekends, these are the amounts. For these type of customers, these are the amounts. So likewise, we can go into deeper analysis of those measurements. For those analysis, we are using dimensions. So basically, we are looking at fact, dimension, and measures. Facts are the relevant events. We will capture them in fact tables. Those are related to the events. It can be sales, shipping, complaints, salaries, you name it. And then analysis of those events can be done from the dimensions. Measures are the numerical properties of those events or those facts. So when we are looking at the modeling, first thing is we need to identify what is the process that we are going to build. Number one, what is the process? What are the events that we want to build? Remember, in an organization, there can be large number of events. There can be many events. So we need to identify what is the importance of out of those existing events. What is the most important event that we should select to model? Remember, in an organization, you can't build you can't model for all events. You have to selective for several events. And then the time. So how long this will need to take to build. Also, you need to have an understanding about the business scenario as well. You can't take ever to build the model. It should be substantial time for you to deliver it to the clients. And then, of course, budget. How long will it take, including the tools, including the resources that you have to spend. So if you look at a end-to-end ER model in a standard relation system or operational system, you can see it's a large number of tiny tables, large tables, combinations of multiple tables. So this is for a property management. You can see the highlighted ones are the related to events. If you look at the property maintenance, property viewing, advertisement, sales, and the leasing, those are the main events with this relevant ER model. So the second one is we need to identify the dimensions. So so we need to identify the fact tables, and then we will need to identify the dimensions. Identifying the dimensions will be discussed in a separate session because it need different other aspects as well. So just parking it here, but in a later session we'll be discussing on the dimensions part. So the next part is the identifying the fact table. Now, fact table or the facts can come in numeric and they can be additive. So if you look at in a dimensions, it can come as a quantity, it can come as an amount as shown here. And then that is analyzed by different properties which are called dimensions. Again, we are not going to detail into dimensions, where today we are discussing only about the fact tables. Right. So when it comes to the measures, these measures can be in different types. Some measures are additive measures. That is, you can add across all parameters. For example, sales amount. Now I can add sales amount, today's sales amount with the previous day sales amount, last week sales amount, and I can say sales amount between this to this. And then there are some semi-additive where the inventory levels. Now, yesterday inventory cannot be added to today's inventory level. Those are some snapshot values. And there are something non-additive. That is, by adding them, it doesn't give you any meaningful idea. For example, you can add them, but that doesn't give you any numerical meaning, such as unit price. So if you just add the two unit prices, that doesn't make any sense. So if you look at these measure types, additive, it can be summed across all dimensions, example, sales and quantity. Semi-additive, you can across some dimensions, but not time, right? Now, for example, I can say inventory level in a one store, inventory level of another store, I can be added those and say, for example, one item is stored in two different locations. Item A has 10 quantities in location A and item A has another 15 quantities in location B. I can add them together and say that, okay, total quantities for those two, that particular item is 50, 10 plus 5, 50. But I can't say yesterday it was 10, today it was 15. I can't say the total quantity is 15, right? You can add across given attributes only. As non-additive, you cannot add them. Ratios, percentages, you cannot add them. Numerically, you can add them, but it doesn't give you any meaningful outcome. So another important factor that we have to think that the calculator and the computed measures. Now, when it comes to OLTP systems, we always have the quantity and the unit price. At the time of need, we will calculate the unit price into quantity and give the final amount. So in the OLTP world, that is fine, because OLTP, we have large number of writes and large number of reads. We discussed this difference in a previous video. So this is where it relates to. Now, but when it comes to data warehousing or analytical platforms, you need large number of reads. So if you start to calculate them as and when need, then the query performance will be slower. So remember, in data warehousing, we are looking at a high number of reads. So therefore, in data warehousing, we save large number of the calculated values. For example, if you have quantity and unit price, there will be another measure called amount, which is nothing but quantity into unit price. And there can be another thing called discount. And you will have another column called amount after discount, which is amount minus discount. Then you will have another column called tax, and you will have another measure called net amount, which is the gross amount plus tax. So that is not a sin in a data warehousing to have different calculated columns in order to improve the performance. Remember, in data warehousing, we are aggregating large number of data. We will be summing up one month data. So rather than calculating them on the fly, it is better to have them calculated in a table, in a fact table, so that we can use it. So remember, in a OLTP, even though we are going for basic measures only, in data warehousing, we always go for calculated measures so that we can use it at a different time. Granularity. If you look at the granularity in OLTP systems, we go for the lowest level of granularity. For example, if you want to store an order, we go for the line item level. But in data warehousing, we don't have to do that. In data warehousing, we can go for a different granular levels. We can have multiple tables even. You can have multiple tables of granularity, the different granularity. For example, I can have a sales fact table, which shows the line item level. That means you have the date, item code, quantity, unit price. And you can have another table for the transaction level. Item wise will not be there. For this particular order, this is the total amount. So then you will have the customer rep date only. Item level details will not be there on that particular table. Also, you can have another table if you wish to. You can, for each customer, by product, by month, what are the sales total. So you can have multiple aggregated tables. So this is a classical example that I can show you. This is a real world example. So this is a data taken for a telco provider. Now let's say I make a call to my home from my office. So customer ID, this is me. Source tower ID is the where I am sitting in. Target tower ID would be my home tower. Time slot is this time slot, and the destination SP service provider is this duration and the amount. So this is a real world case which we did around 10 to 15 years ago, or just more than that. When we're looking at this, we realized there were 26 million records per month. 26 million records per month for this level of data. But we realized this first 5 parameters, customer ID, source tower, target tower, time slot, and the destination tower, if we can aggregate that, we can reduce it to something around 18 or 20 million records. So 25 to 20 million records. You are reducing 5 millions of records per month. Remember, I'm not talking about the storage here. Storage is not a major concern in data warehousing, at least in this era. We are looking at the performance. We are looking at the performance. And if you look at their business scenario also, their business scenario is to analyze the tower loads. Their business scenario is not to send detailed bills. So remember, in data warehousing, we are not going to replace the existing transaction or core system. That will be there. Even we summarize here, if you want the detail bill, still you go for your source system. So don't come into the myth that we are going to generate standard reports from data warehouse. Data warehouse is for analytical purposes only, nothing else. Right? You are not going to replace the existing system. This is an add-in for our users to do their analysis. So we were able to aggregate this. But one thing to remember, when you are aggregating, you are losing some information. You will be reducing some information. Now, you have to be very careful when you are reducing it. So here, when we are reducing it, we got the total duration, total amount. Also, we add another column called number of calls, in case they need to know how many calls. Tower loads were important. So in case they need to know how many calls, we included that as well. Now, remember, when it comes to fact table, you can't change measures as and when you need. And be very careful when defining these measures. Be very careful when defining these measures. So when you are summarizing it, you have to plan it. So my take out this is, okay, you define your original granularity as well as the aggregated granularity. Don't remove the original granularity. In case of a need, you can have that as well. Right? So data duplication is fine in data warehousing. So in the data warehousing, you will have this table as well as this table. So you will end up with 2 fact tables instead of 1. That is fair enough in data warehousing. So these are taken from the Kimball's book. The book is available for you to read. These are the fact tables that you can find, typical fact tables, transaction, periodic snapshot, and the accumulating snapshot. Fact tables are there. So I will just discuss this through in the next slides. So transaction fact tables, you will see the fact table here. So these are as and per transaction, you will get the fact table. Inventory transaction, transaction number, amount per transaction, you will get the fact table. So as and when you get the transaction, you will see a fact table here. So the next one is periodic snapshot. That is, it's not as and when you get the transactions. As a snapshot, month end. So this one is month end. Month end, these are day end inventory snapshot. At the end of the day, for this particular product, this particular store, this many quantities in hand, these are the quantities sold for that particular entire day, the cost and the latest selling price. So you have a one record per day, per store, per product. So in HR, this is the people are doing this month end per department, per organization. These are the employees month end. So then we have something called accumulating snapshot. I will explain the accumulating snapshot through an example. So these all examples are taken from the Kimball's book. So now sometimes when you receive a transaction, that details are not completed that time itself. They will be accumulated later. Now, for example, it's like this. So this is you receive an order. This is the receive date. So you will get for the product number 1, you get 100 items were received. On a subsequent day, after 2 days, you will say, okay, you inspect it and you are saying 2 quantities are left. And then you are placing it on a bin on another after another 1 day and you are saying another 3 items are left. So it's a accumulating. Until you receive the transaction, you are placing it to the bin, it's accumulating because it doesn't happen on the same day, right? So these are little rare and these are little the performance wise not very recommended, but there can be cases where we need to adapt to this type of design. Then there's another interesting table. There is a factless fact table. Now there are events but doesn't have a measure. Now, for example, you enroll to a course. You are there, course is there, date and time is there. What are the measures? No measures. Right? No measures. Accident. Driver, car, place, measure will not be there unless if you think, okay, we can quantify the damage. Right? So there are factless fact tables are also there in mostly subscriptions. Of the you can say that the enrollment subscriptions are mostly the common cases for factless fact table. So these are the classical example. So you can see in this fact table all are other keys and there is no measures. So typically what we do is we will have a column called accident involvement count or some measure. It is nothing but just a 1. So that when you are summing it up, you can easily sum this column measure and say total number is this, average this number, and you can get that. So that's the whole idea. So it's an arbitrary value that we introduce when it comes to factless fact table. So we theoretically we don't have a measure, but we introduce a measure to make our work easy. Right. So these are the summary of the fact table. So we will have the fact table. And there are the transaction and snapshot fact table. Transaction tables record these with the time. Snapshot table record the status as a regular intervals. Factless fact table, these tables contains no numeric measures. What basically to understand what happened. And then yeah, so then defining the grain is a very important factor when it comes to fact table. And also there are 3 types of measures: additive, semi-additive and non-additive. And also we will have the way of defining. First we need to identify the business process, then you define the grain, granularity, and then we identify the dimensions and fact table. So we have few questions for you. Let's discuss this question during the class. Before that, bring your answers to these questions. We'll be discussing these questions in the class. If you have any questions, we can discuss them. And this is our in-class work that we do in the class. So we will be going through your projects. We have done some work for your project. So today we'll be doing our your individual work for your development project. We'll be doing the design at the start. Hope you understood this very basic concept. Let's do this in detail in the class. Thank you very much, and we'll see you in the class.